Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Right, so the 2012 calculus question was quite, I suppose, difficult but doable calculus question. Let f of x equal e to the minus a half x squared. Show that the second derivative of f of x with respect to x is f double dash x is equal to bracket x squared minus 1 e to the minus a half x squared. Okay, so the first thing is if we're going to get f double dash of x, then we need to find f of x first, or f dash x, okay, because this is the second derivative, so we have to get the first derivative first. Okay, so when I look at f of x being equal to e to the minus a half x squared, I see the e function, okay, and I also see quite a complicated little power. Okay, so this is most definitely a chain rule because, no, I put my box wrong around that. I just wanted to draw my box around the power. Okay, it's most definitely a chain rule because this inner function, this minus a half x squared, in itself is a function. In other words, if I gave you that y is equal to minus a half x squared, could you differentiate it? Yes, you could. So that makes a function, that makes it a function in its own right. And then of course, all of that is housed within the e function. So it is definitely a function within a function, or these two functions, the minus a half x squared and the e function, are chained together. Okay, I find it easier to break out the inner function and I just call it u. Now don't confuse it with the product rule or the quotient rule. U and v just tends to get used for everything in calculus, but I'm letting u equal to that minus a half x squared. So therefore, when I differentiate that inner function, it is minus a half, that's a constant, so leave it there, take down the power, reduce the power by 1. So minus a half by 1, sorry, minus a half by 2 gives me 1. So I'm going to get minus 1x or minus x. Okay, so that's the inner function. And then you can do this in two ways. I'm going to do it informally first, where e to the power remains as e to the power. Okay, and then I multiply it by the inner function differentiated, so that I end up with minus x e to the minus a half x squared. So that's my f dash of x, okay? And that's your full answer there for f dash of x. Okay, now just to be able to see that, if you couldn't see it, what exactly am I doing? So a formal way of doing it is when I let u here equal to minus a half x squared, I could have written f of x as e to the power of u. Okay, so therefore dy du in that case then is, you can see from the log tables, e to the power of u, e to the power of x remains the same. So that is why this one here is e to the power of u. Okay, and then so what I'm really doing is kind of what's down here. I'm breaking them into two different parts. I am calling the letters slightly different, and now I'm bringing them back together. So dy dx then is the e function, and I multiply it by the inner function. So the main function is dy du, which is e to the power of u, and then du dx then is the inner function. Okay, du cancels, so you can see how I end up with dy over dx, and I get e to the power of u from here, and I multiply that by the minus x that's up here. Okay, You sub back in for u, because remember we let u equal to minus a half x squared by minus x, so minus x e to the minus a half x squared. Okay, that suits some people's way of thinking. That is the formal way of doing calculus. And that is how I did calculus in third level. And it was the only acceptable way of doing it in third level. This informal way where you just literally write down the answer was not accepted, okay? But you get the same answer. So you have to play to how your brain thinks. You have to play to whichever way makes more sense. The way I did it down here in blue, or the way I did it up here in black. And of course, this applies to both of them. Okay, so that's f dash of x. We're not done. So I'm just going to clean off the blue now. It is on the recording. So make sure you go back and see if that's for you. Okay, and I'm only clearing it off to give myself some space. So that's f dash of x. So if I have to get f double dash of x, then I have to differentiate this again. Okay, so f double dash of x is just means take f dash x, differentiate it again. Okay, except in this case, we have a product because there's a function and there's a function. Okay, so we have it a chain within my v function. Perfectly normal, perfectly acceptable to have a complicated u or v. My u doesn't look so bad. Okay, so in this one, let me write down my product rule from here. Y is equal to uv. So when I differentiate it, dy dx, or of course f dash of x, it is u comes first, u times dv dx plus v times du dx. Okay, so I need to set up these four pieces, u and v, dv dx, du dx. So u is equal to minus x. That's my first function. V is equal to minus a half x squared. Du dx is equal to minus 1. dv dx, okay, of course you can differentiate it again, but you can also see that this is the exact same as the original f of x up here. Okay, so in that case, I can say this is equal to minus x e to the minus a half x squared in brackets from above. We have already differentiated e to the minus a half x squared. We know it will be minus x e to the minus a half x squared, so I don't have to do it again. So dy dx in this case then is u minus x times dv dx minus x e to the minus a half x squared plus v e to the minus a half x squared times minus 1. So let's tidy that up. I have minus x by minus x, so that's going to be an x squared e to the minus a half x squared minus 1 e to the minus a half x squared. Okay, that looks good. I could factor out the e to the minus a half x squared. That's definitely doable. Let's look up at our answer though to see how do they want it. Yeah, they want us to factor out the e to the minus a half x squared. So e to the minus a half x squared, factor that out and I get x squared minus 1. Okay. Okay, so really does examine your product rule, your chain rule, and whether you knew what second derivative is. So a really good question. So if you manage to get that, and feel free to pause any of the videos, try them, see how you get on. If you got that, then well done to you. Okay. Let's look at point B, part B. The point P in the first quadrant is a point of inflection of the curve y is equal to e to the minus a half x squared. Show that the tangent at P crosses, or the tangent at P crosses the x-axis at 2, 0. So that point P is a point of inflection of the curve y is equal to e to the minus a half x squared. A point of inflection is a turning point. The easiest turning points to get your head around are a max turning point, which is up here. Okay, that's a max turning point. It turns. The slope turns from being a positive slope to a slope of 0 to a negative slope. Okay, you can of course have a min turning point, which is the same as max really, but the opposite. So a negative slope to a slope of 0 to a positive slope. Or you can have a point of inflection, and I'm not very good at drawing them, but I will try. It's where you're going down and you have like an inflection in the curve. So it's not that the slope changes. You have a negative slope going down there. You have a slope of 0 still here. And then you still have a slope of 0. Whereas this one was plus to 0 to minus, or minus to 0 to plus. So in other words, the slope changed from positive to negative or negative to positive. With the point of inflection, it doesn't. It keeps going the same way, except with this inflection in the middle. Okay, so that's what's happening there at P. It is one of our types of turning points. And what they want you to do is show that the tangent at P crosses the x-axis at 2, 0. So this point down here is 2, 0. Show that the tangent at P crosses the x-axis at 2, 0. Okay, well, the tangent is a line. That's the first thing to remember. And if I have to figure out where does a line cross the x-axis, I would get the equation of the line and then sub it in at the x-axis. My y coordinate is 0. And I would see what x value it crosses the axis at. Okay, so that's how I would do it for any line. So I'm going to try and see if I can make that work for here. So to do that then, to find the equation of a line, it is always y minus y1 is equal to x minus x1. So I need a slope. That's okay, that's calculus. Calculus does give you the slope of a curve. So that looks like it's okay. I need a point x1, y1. So yeah, would be nice to find out that point P if we could, wouldn't it? Because what is P? Because that would be my x1, y1. So that's what I'm thinking. That's where I'm going to go. I'm going to give that a shot. Okay, so I hope that makes sense. So when you're faced with a question like this, you're literally going down through theory of any chapter, not just theory of calculus, but theory of any chapter to see what do I know about that type of question, regardless of the question that it's asked in. So I suppose what I'm saying here is this is a calculus question, but I'm going back to coordinate geometry, the line, because the tangent is a line, and seeing, well, what tools do I have there that could help me solve this one? So I suppose point P is the first thing to do. So how do we find point P? Well, what do we know about point P? Well, the point P in the first quadrant is a point of inflection. Okay, so some more theory. So points of inflection. So to find turning points, you let dy dx equal to 0 and you solve. Okay, and that will give you the x coordinates of however many turning points is in that function. Okay, now to find the nature of the turning points, and when I say nature, I mean what type of turning point is it? You need to find d2y dx squared. Okay, and then d2y dx squared is less than 0 if it's a max, it's greater than 0 if it's a min, and it's equal to 0 for a point of inflection. And POI is often used in this chapter as shorthand for point of inflection. Okay, so that's the theory behind turning points. That's what you need to know when you see any kind of a turning points question. So now how do I use it? Well, it's a point of inflection. So therefore, my second derivative, which is x squared minus 1, e to the minus a half x squared must be equal to 0. It has to be that if it's a point of inflection, because that's what the theory down there told me. Okay, that's already written as its factors because we took this out. Okay, so there's one factor and there's one factor. So just like you would a quadratic or any other type of such equation, you let each of the factors equal to 0 and you solve. Sorry, that's the power. Okay, so the first thing I'm going to do is I'm going to discard this one. Okay, why? Because I see an e function there, and then you can only get logs of numbers greater than 0. So you can't get logs of numbers equal to 0 or negative numbers because you get a maths error. Okay, so x is in the power there, or yeah, is in the power. So to be able to solve it, I need to use logs. Okay, so this is the only one that I have. So x squared minus 1 is equal to 0. X squared is equal to 1. X is equal to plus or minus 1. So watch out for that one when you're getting the square root of x. Square root of x, the original x value could have been minus 1 or plus 1, because minus 1 by minus 1 also gives you plus 1. So x is equal to plus or minus 1. Which one is it, or is it both? Let's go back here because it tells us we're in the first quadrant. Okay, so x equal to 1 is here, x is equal to minus 1 here. So therefore, x is equal to 1 in the first quadrant. Okay, so that's my x value of p, my point of inflection. I've just solved the second derivative for x, and that has given me the x value for my point of inflection, which is p. So there's obviously another point of inflection over here. That's what I got with the minus 1, but we don't care about that for this particular question. So there's my x coordinate there, which is 1. I'm just after filling it in over here. Okay. I now have to find my y coordinate. So when you're finding a y coordinate in any calculus, you sub into the original equation. Okay, and when I talk about the original equation, I'm talking about the f of x one, because f of x is y. It is in functions, it is in any chapter, okay? So we want to find y. We don't want to find dy dx, which is slope. We don't want to find the nature of a turning point, so we don't sub it into the second derivative. It is always into the original. Okay, so f of x then, so when x is equal to 1, f of x is equal to y, which is equal to e to the half of 1 squared. And you can put that into the calculator and you will get e to the minus a half. Okay, and of course you can change that to decimal if you like. I don't, but that's the engineer in me, because I don't. I like precision and I don't like rounding. So I would be quite comfortable leaving it as e to the minus a half. But nothing wrong with you at all putting it into your calculator. Do you see it's over there just above the AC button on the extreme right? So it's sitting behind my ln button. So e to the power of minus a half, and I'm getting 0.606 for that, or 0.607 if I round it properly. So that's my point P. So I'm going to put my y coordinate in here now as well. So it's e to the minus a half. Okay, so we need the equation of a line. We need to find the slope first. So I have my x1, y1 now. Let's find our slope. So the slope at P, okay? Or in other words, what is that slope? What is dy dx, or f dash of x, when x is equal to 1, because isn't that the x value at p? Okay, so f dash of x when x is equal to 1 is equal to, what was my f dash of x again? It was minus x e to the minus a half x squared, because we had to do a product on it. So it's equal to minus 1 e to the minus a half 1 squared. Okay, so for my slope, I'm getting minus e to the minus a half. Loads of minuses. Okay, so then y minus y1 is equal to m times x minus x1. There's my point P. There's my slope. So y minus e to the minus a half is equal to minus e to the minus a half times x minus x1. Okay, let's multiply that out. Y minus e to the minus a half is equal to minus x e to the minus a half. Minus by minus is a plus, e to the minus a half. Okay, I'm going to bring this over this side, just like I would with any other equation. So y is equal to minus x e to the minus a half plus e to the minus a half plus e to the minus a half, because of course this one changes sign when I bring it over. So I am getting then, for the equation of that line, y is equal to, I hope I'm not going off the page for you, minus x e to the minus a half plus 2e to the minus a half. Okay, so that's the equation of the line. Okay, I'm just going to rub off this theory now over here just so we can finish it off, because I have to show that the tangent of P crosses the x-axis at 2, 0. Okay, so I will write down here at the x-axis y is equal to 0. Okay, so I would put into this equation here, I would let y equal to 0 so that I get 0. Well, I might write it the opposite way. Minus x e to the minus a half plus 2e to the minus a half equals 0. So that's my y. I just put it over the right-hand side because in my head it looks easier, but doesn't make any difference at all. Minus x e to the minus a half equals minus 2e to the minus a half. Okay, change the signs all the way across because I want to solve for plus x. Divide by the number in front of x. So I'm getting x is equal to 2. Okay, therefore, the tangent at P crosses at x coordinate first, y coordinate. Okay. So kudos to you if you managed to get that question out, but do practice it because it really does test your skills at second derivative.
If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.